In this video, we are going to talk about how to solve systems of linear equations by graphing. Now, there are three types of solutions that you can get to a system of linear equations. Let's take a look at this first one. If the lines intersect, they're going to have that one point in common. That one point is the solution to the system. If the lines are parallel, they do not cross, they have no points in common, so you would say there's no solution to this system. And then finally, if the lines are actually identical and they overlap, every point on that line would be a solution. So there are infinitely many solutions in that case. Now let's look at an actual example. So there are 5 steps that we're going to do to solve the system of equations by graphing. You'll see there are 2 linear equations, and let's go through that process. So our first step says to graph the first equation. Now, how would we graph 2x minus y equals negative 3? Well, I think it's a really good idea if we take and we solve that for the y. So first I move the 2x to the other side. You'll see it becomes a negative 2x. Divide everything through by negative 1 to get that y equals mx plus b form. Now you might recall that gives us the coefficient Rx is our slope, so our slope is 2. So we're going to go up 2 over 1 from our starting point. Now what's our starting point? Well, our starting point is our y-intercept, or on the y-axis we hit the point 3, so it is the point 0, 3, so right here. So first take and draw that point, or put that point on your graph, that point 0, 3, that y-intercept of 3, and then count up 2 over 1 to find another point, and then connect it. Now, if you want more than one point, you could go up 2 and over 1 again. That will also get you where you want. So you've graphed the first line. And then our second step says to graph the second equation on the same rectangular coordinate system. So let's take our second equation, x plus y equals 6. Let's do the same thing. Let's rearrange it. Let's solve it for y. Let's put the negative x on the other side, so we get y equals negative x plus 6. So how would we graph that one? So our slope is negative 1. Our starting value is 6. So we're going to start at a value of 6. We're going to count down 1 and to the right 1. So you'll notice here that was our original, my first equation. Here I started at 6. I went down 1 over 1, down 1 over 1. You definitely want to cross through the red line so we can see the point of intersection, because our solution is that point. In this case, they intersect at the point 1, 5. Now, there's some disadvantage to solving systems of linear equations by graphing. You want to be very precise. You want to make sure you use a straightedge of some sort and that you're as careful as can be, or you might not see that it's clearly a 1, 5 intersection. But we should check it. That's what our 5th step says. So to check it, I'm going to plug the point 1, 5 into our first equation. I'm going to go back to that original form. And you'll see that I get a true statement. Negative 3 does indeed equal negative 3. But you should check it in both equations because it has to be a point on both equations. And if you plug it into x plus y equals 6, you do indeed get 6. So that is how you can check your work. So that's a little bit about how you solve systems of linear equations by graphing. Thank you so much for watching. Have a good day.